All right, welcome back, everybody. So we got the warm-up here on the board. Again, if you're watching along at home, make sure you pause this, try the warm-up, and then press play whenever you're ready to see the answers. Okay, for number 4, we just talked about this in the classroom, but remember that 10 to the 6th is just really a number, just a number. And if I'm thinking about what the formal definition of a degree is, it's the powers on the variables, right? It's the exponents on the variable. So the degree there, since it's just a number, the degree would be 0. Okay, somebody tell me, what's the degree on number 6? What's the degree on number 6? Okay? 8. Just quite simply 8. Good. You look at the variable, it's 8. Let me pull some names. It's Monday. People aren't going to be willing to volunteer. All right, number 8 there. Now, remember for this, if I'm talking about a full polynomial, I find the degree of each piece and then take the biggest one. So Joey, what's the degree of that entire polynomial for number 8? 2. Very good. The degree here would be 2. The degree here would be 1. The degree here would be 0. So the full degree is just 2. Don't add them together. That's the degree of a monomial, one single term. The degree of that polynomial would be 2. We have number 10 here. Hayden Tripp, what's the degree for number 10? It would be 3. Good. Degree here is 1. Degree here is 3. This is 0, and that's a 2. So the highest one, the degree would be 3. And number 12, Hayden. Right. Good. The degree would be 3. This is a 3. This is a 2. This is a 1. Good. Questions on that then? Now, can somebody tell me what does it mean in standard form? How do I write something in standard form? Alex?
Greatest to least in degree.
Good. Greatest to least in terms of the degree. Greatest to least in terms of the power. So for number 14, I would write it like this. B squared, because that's my highest degree. Then bring down the minus 2b. Then bring down the plus 5. Okay, rewrite the terms in order from biggest to smallest degree. Now, remember that leading coefficient is just the number all the way out front. So I would look out front and say, okay, what's the number right in front of b squared? 1. So my leading coefficient would just be 1. Okay, let's take a look at that with number 16. First one here, it looks like it would be negative s to the 7th. Again, yes, carry along the negative. Negative s to the 7th. Then we have a 5s squared minus 3s plus 3. So somebody tell me, well, I guess, Nate, what's my leading coefficient in that one then, for number 16?
Would be negative 1.
It would be negative 1. Good. It would be negative 1. Because you would look out here and say, okay, what does that mean? Well, that's a negative 1 sitting out on the front. All right, and my last one here, I would write a g squared plus 5g minus 7. So what is my leading coefficient for this one, Mason?
1.
Positive 1. Good. My leading coefficient would be positive 1. Good. Now, how do I know that I'm going to have to name the polynomials using what we've already gone over? Well, whenever I say classify, classify means to name. All right, so I've got to write the degree and the number of terms. So, Berkeley, what's the degree here?
Quadratic.
Good, so it's 2, so it's a quadratic. And how many terms does this have?
3, so it's a trinomial.
Good. Quadratic trinomial. Good. Number 22, Mr. Schrembeck. What's the degree for number 22? Well, I'm talking about degree. That's number of terms. What's the degree on this? It's not quadratic. The degree is 4. So what would it be? quartic. And then it's got 3 terms, so what would it be? Trinomial. Okay, and then here, Will, what's the degree? The degree would be 3, so what is it called? Good. And then how many terms does it have? And what would that be called? Good. So that would be a cubic binomial. Guys, you don't have to write the d equals t equals. This is really all I need for all of those. Just the name. Okay, just the name. People, do you have to memorize those? Yes. I'm telling you right now ahead of time. Okay, do whatever you need to do. Make flashcards, whatever. All right, let's go over the homework. So get out your homework. I'll ask you to go over some of these problems. Alexis, what'd you get for the first one, number 28, degree? 1. Good. Number 30, Kyler? Good. What'd you get for number 32, Hannah? Good. And what'd you get for 34, Ben?
0.
Good. Any questions on those? Those are some easy ones there, too. Let me ask you this. This is kind of a side note. If I had 3x to the 4th, y to the 2nd, what would be my degree? 6. This is the one where you would add them up because it's a monomial, single term. Do you see any plus or minus signs in between the 3, the x, and the y? No. So this is a single monomial, and by definition, you would take the sum of the powers of the exponent. So 4 and 2 together, that would be a 6 degree. All right, so let's take a look here. Find the degree of each polynomial. Number 36, Travis, what'd you get for 36? So tell me, what would it be? What would the degree there be? 1. Good, it would be 1. It's very tempting to say 2, but it's not 2. The power on the number is 2. What's the power on b? 1. So the degree here is 1. Mackenzie, what's the degree for 38?
8.
Good. 8. And number 40, Elena? Oh, sorry, you weren't here. Rosalie? For number 40, what's the degree? Good. Questions on any of those? Okay. And let's take a look here. Write each polynomial in standard form, then give the leading coefficient. I'll do some of these. First one here should be negative 10a squared plus 8a plus 2. So my leading coefficient is a negative 10. Number 44, negative 3m squared minus m plus 7. So my leading coefficient is a negative 3. Number 46, negative n squared minus 2n plus 1. So my leading coefficient would be negative 1. And number 48, 12s to the 3rd plus 3s squared plus 6. So my leading coefficient would be a 12. Questions on any 4 of those? We're good there? All right, let's keep it going then. Let's name David Haas. What would this first one be? What's the degree there? So what would it be? Constant what? Constant monomial. Good. Constant monomial. Number 52, John. What's the degree?
3.
Good. So it would be a what?
Polynomial.
No. Watch out.
Oh. Cubic.
Cubic. And then how many terms does it have?
3.
Cubic what?
Trinomial.
Cubic trinomial. Good. Cubic trinomial. Number 54, Liam. What's the degree? So it would be a
Linear binomial. Or quadratic binomial.
Quadratic binomial. Good. Quadratic binomial. And number 56, Serenity. What's the degree? 3. So it would be a, and then how many terms? Which one? We're talking about 56. What did you say? It's not 2. Three terms. So it'd be a cubic trinomial. Remember, term means anything separated by addition, subtraction, sign. So cubic trinomial for that one. Number 58, all I'm really asking you to do here is just plug that 30. This is kind of exact same problem that we had in class. Plug that 30 into, for V, so 3.675 times 30 plus 0.096 times 30 squared. Let's see what we got. 3.675 times 30. Oops. Wrong way, parentheses. Plus 0.096 times 30 squared. Safe stopping distance is just under 200 feet. 196.65. Questions about that one? Okay. Last set here. Tell whether each statement is sometimes, always, or never true. A trinomial is a third degree. Well, third degree is cubic. Does trinomial always mean it's cubic? No. Can it mean that it's cubic? Yeah, but not always. So we would say sometimes. That would be a sometimes. A polynomial has 2 or more terms. Can a polynomial have one term? Is a monomial still a polynomial? Yes. Technically, yes. Yeah. So a polynomial has 2 or more terms? Sometimes. That's another sometimes. Because we have an example, we have a counterexample, but we have examples where it's true as well. A binomial is a polynomial, a trinomial is a polynomial, and so is a monomial, so is one term. All right. Okay, so hopefully that clears some stuff up with section 7.5. Let's talk about section 7.6, shall we? Now, section 7.6, in my opinion, much easier than section 7.5. What we're going to get into now with section 7.6, 7.7, and 7.8 is we're going to learn how to operate with polynomials. Okay? We're not really going to learn how to divide, but we're going to learn how to add, subtract, and multiply with polynomials. Today is adding and subtracting. And you're going to find, at least I hope you find, that adding and subtracting with polynomials is like something that we've already done. Really, it's just like combining like terms. You guys know how to combine like terms? Then you know how to add and subtract polynomials. Okay? Simple as that. Okay, so just as you can perform operations on numbers, you can perform operations on polynomials. To add or subtract with polynomials, you basically just combine like terms. That's really it. If you know how to combine like terms, you already know how to add or subtract polynomials. Because honestly, that really is just like adding monomials together or subtracting based on the sign. Remember, like terms are terms that have the same variable raised to the same power. You can't combine unlike terms. They've got to be exact same variables raised to exact same powers. We talked about that already. All right, let's take a look at an example here. Now, this is something that I could have given you on like the chapter 1 test, right? This is something that we did at the very, very, very beginning of the year. What are like terms and combine them, okay? But now we know a little bit better about them. Can't we say that, these are all 3 little monomials, right? If I'm adding these 3 monomials together, but I'm only going to add together the ones that have the same degree. Well, 12p to the third. Is there another p to the third? Yeah, the 8p to the third. So what do I get? 20p to the third. And remember, you leave the exponent and the variable the same. You only change the coefficient. You only take the 12 and the 8. And since it's positive, 12 plus 8 gets me 20. Now, can I add the 11 with it? No, I cannot. Because it's a different power on the variable. It's the same variable, but a different power. You can't make that like 31p to the 5th. No, you can't do that. Okay? You've got to leave them separate if you're adding and subtracting. Here's the rule that we're going to follow throughout this. Always write answers in standard form, going from biggest to smallest in terms of the degree. It would be wrong to say that this would be 11p squared plus 20p to the 3rd. You know how all along you've been saying, okay, does it matter the order in which I put these? And I've been saying no. At this point, that answer changes. At this point, I say, yes, it does matter the order in which you write them. You've got to go in order from greatest to least in terms of the degree, as long as you can put it into standard form. I can put this into standard form because I see only one variable, right? If it's got multiple variables like b, which we'll get in a second, then you could possibly put it into standard form. All right, are there any, so let's go in standard form. My biggest power is my x squared. Are there any other x squareds to combine with it? No. So we just bring it straight down. That goes away. My next biggest power is the negative 3x. Are there any other negative 3x's to combine with it? No. I should have said any other x's to combine with it. Negative 6 and positive 8, what does that make? 2. Just quite simply 2. It's us a quadratic trinomial, isn't it? See, now we can be really fancy. Now we can like use our $10 words and sound really fancy. See this one. I guess I could have said this one. I can't possibly put this into standard form. So order for this one doesn't really matter because it's got two different variables. What I like to do is I like to go in alphabetical order. So what comes first? S or T? Q, R, S, T, U, V. So S should come first. So let's go with the highest power on S. Are there any other S squareds? Yes. So I've got a positive 2 and then minus 1. So just 1 S squared or just S squared. And those will go away. And now we do the T's. I've got a T squared and a negative 4T squared. Well, minus 3T squared. Good. It's not technically in standard form because there's two variables. It's technically still okay to write negative 3T squared plus S squared. But I like to write it in alphabetical order. Let's take a look at this one. Oh, it's interesting enough here. Are these all like terms? Yes. Yes, these are all like terms. I've got a 10m squared n, a 4m squared n, and a negative 8m squared n. So what does that get me in the end? 10 plus 4 minus 8. 6. Leave the variables the way they are. 6m squared n. Gets me a monomial in there. So I hope you would see that in example 1, everything that we've done so far, those are just monomials being added together. So what if I had binomials and trinomials being added together? Well, honestly, it's a lot of the same thing. Let me ask you this. Do those parentheses really matter at all? No, because I'm just adding. So honestly, if it's an addition sign, those parentheses don't really matter. And if they don't really matter, doesn't this turn into a problem like I just had? Yeah. Okay. Now, we can talk about it in a different way. Based on those parentheses, what I had, I already erased them. But based on those parentheses, I have a binomial times a trinomial. I have a quadratic binomial plus a quadratic trinomial being added together. And then we can sound really fancy and impress our friends. Maybe not. I don't know. What do your friends think of your math abilities? 5m squared. Let's bring down our minus m. And then what's the number that should sit out on the end? 11.
So it matters where the negative m goes.
Yeah, because it should go squared to the first power and then my constant. Should go in order. Take a look at our next one here. Again, do our parentheses matter? No. So just act like they're not there. Now, I can't possibly put this into standard form because I've got two variables going on. So let's just take our first one. I've got 10xy and a negative 3xy. What do I get? 7xy. And then it looks like I've got a plus x and then a plus y. And that's it. Could these go in any order? Yeah. X plus 7xy plus y? Sure. Y plus 7xy plus x? Sure. Doesn't matter. Try the last one on your own. Try C on your own. Okay, let's take a look here. Are there any other x squareds? Yeah. I've got 3 total of them, right? 6, 3, and negative 8. What's my final coefficient on x squared?
1 to x.
Good. So it's just 1x to the second, or x to the second. And those all go away. Oh, look, I've got x's and y's. So I guess I could have put the y's first. Standard form doesn't really exist here. Negative 4y, positive 3y, negative 2y. All right, so what do I get in the end? What was that? Negative 3y. So I'm going to say minus 3y. Please don't say plus a negative 3y. It's minus 3y. Don't say plus a negative. Say minus. All right, so that's addition. Pretty, not so bad, right? Just combining like terms. All right, flip it over. Now, remember, to subtract is really just to add the opposite, right? We talked about that at the very beginning of the year when we were just adding and subtracting numbers, right? I said you could change every subtraction problem into an addition problem just by changing the sign. The same thing is true, but now when we change the sign of the polynomial, like if I have something over here, like consider this, there's like a polynomial on the left side here, minus this cubic trinomial. Really what I want to do, because there's a negative sitting in front of this parentheses, is I want to distribute that negative into the parentheses. In essence, all that really does is just change the signs of every term in the parentheses. So the positive 2x to the third becomes negative 2x to the third. The negative 3x becomes a positive 3x. The positive 7 becomes a negative 7. And then we just combine like terms. Okay? All right, so let's try it. You know, honestly, if I just distribute into this monomial, the first stays the same. Remember, never change the first polynomial. This just turns into a minus 2x to the third. Because there's only one thing to distribute it into. It's positive inside parentheses, so it becomes negative on the outside. All right, x to the third and negative 2x to the third. Got it, please. Thank you. Negative 1 x to the third plus 4y. Do I need the negative 1 there? No, I just write negative. Okay. Again, that one was kind of a little weird because there was only one thing to distribute the negative into. The next problem, there's more things to distribute the negative into, so let's do it. Before you start combining, you need to distribute that negative into the right side. You leave the left side polynomial exactly the same. 7m to the fourth minus 2m squared, and now this becomes a minus 5m to the fourth, a plus 5m squared, a minus 8. Parentheses go away, and now I combine like terms. This is just m's, so it should be in standard form. Got an m to the fourth and an m to the fourth here. 7 and a negative 5 make a positive 2 m to the fourth. Negative 2m squared and a positive 5m squared make a positive 3m squared. And then bring down our minus 8. Can someone name that for me? What would the classification be for that? Well,
That would be a quartic trinomial.
yeah, good. Quartic trinomial. The degree is 4, so I would say quartic. It's got 3 terms, so quartic trinomial. Let's take a look at our last one. Last two. Sorry. I distributed my negative. I distributed my negative to here and here. I leave my entire first polynomial exactly as it is. I don't change any signs for my first one. I only change the second one. It becomes a minus x squared, and then what? Plus 9. And now we combine my terms. Negative 10x squared and a negative 1x squared. Negative 11x squared. Looks like I've got a minus 3x and nothing else to combine it with. And then 7 and 9 make 16. Okay, try the last one on your own. All right, so my last one should look like this. Bring that negative in. Leave the one on the left side, r squared, s squared. And then we should have a negative 5r squared minus 4s squared. Does standard form exist on this one? No, because I've got two different variables, q, r, s. Okay, so r's should come first. Negative 4r squared, s squared, and a negative 4x squared should be negative 3s squared. If you had that reordered, it would not change anything. I would have to accept that. Negative 3s squared minus 4r squared, that would be fine too. That's just kind of like a Mr. Lambert rule. That's not like a math rule. Okay. All right, I'm going to pull up the pages because you might be able to get a good chunk, or at least a little bit of it done right now. We got page 47. Yeah, this is chapter 7, page 47. Because honestly, it's just combining like terms, so you might be able to get a portion of this done right now. Yeah, 16 to 24 even down here. 25 to 34. Well, I'll just leave it right here. Yeah, look, you could get a bunch of that done right now. Just adding and subtracting, combining with terms.
That looks like a lot of work.
But is it?
Yeah.
No.
It's not really. That's the thing. And that's what you guys have to get past. You're just combining like terms. This first part, 16, 18, 20, 22, 24, should take you like 3 minutes. If it takes you longer than that, then you're doing it wrong. Just because something looks difficult does not mean that it is difficult.
She's not me, then I got in trouble.
That does not happen.
What?
He's lying. No,